Now let us discuss about Strassen's matrix multiplication. It is an application of divide and conquer algorithm strategy. We have various divide and conquer algorithm strategies like merge sort, quick sort, binary search, finding the maximum and minimum element, and one more application of the divide and conquer algorithm is Strassen's matrix multiplication. Here generally we can do matrix multiplication in three ways. The first way is conventional or traditional or standard way of matrix multiplication. There we will get time complexity as big O of n cube. Second way is divide and conquer strategy of matrix multiplication. Here also we will get a time complexity of big O of n cube. Whereas the third one is Strassen's matrix multiplication. It is extremely faster when compared with the first two strategies. Here the time complexity is big O of n power 2.81. So now in this video we are going to discuss about these three ways of matrix multiplication. First let us see about conventional method of matrix multiplication. Let we have two matrices. The first matrix is A, second matrix is B, and the resultant matrix is C. So here the order of the matrix is 2 by 2. The elements of A are A11, A12, A21, A22. So first row first element, first row second element, second row first element, second row second element. So likewise we have B and C. We know that matrix multiplication is possible only when the column size of the first matrix is equals to the row size of the second matrix. Here the column size of the first matrix is 2, row size of the second matrix is 2. So both are same. So then only the matrix multiplication is possible. So we know the logic for how to multiply 2 by 2 matrix using a conventional way. So we have to multiply the first row, the ith row of the first matrix with jth column of the second matrix. So first we have to multiply first row of the first matrix with first column of the second matrix. So that element is C11. So C11 equal to A11 into B11 plus A12 into B21. So likewise C12 is nothing but we have to multiply first row of the first matrix with second column of the second matrix. So A11 into B12 plus A12 into B22. So likewise C21 means second row of the first matrix is multiplied with first column of the second matrix. So A21 into B11 plus A22 into B21. Likewise C22 is nothing but second row of the first matrix is multiplied with second column of the second matrix. So A21 into B12 plus A22 into B22. Now let us see the algorithm. Already we have seen this algorithm in C language. So totally we will use 3 for loops. So the first for loop is for row repetition. Here the row value, column value is n. So for I equal to 0, I less than n, I plus plus. And the second for loop is for column repetition. For j equal to 0, j less than n, j plus plus. This is algorithm. So that's why we are using this syntax. We are not using like C of I is one index, j is another index. We are not writing like this. So this is a two-dimensional array. But this is an algorithm. That's why we are using only one subscript. So C of ij equal to 0. Next for that multiplication and adding. So we are using this for loop. So for k equal to 0, k less than n, k plus plus. We know the logic. C of ij plus equal to. That means C of I comma j equal to C of I comma j plus A of I comma k into B of kj. So this is the logic for conventional matrix multiplication. So C of ij equal to C of ij plus. So that's why we are using plus equal to. Plus equal to is nothing but is equal to A plus B. A plus B, A plus equal to B is nothing but A is equal to A plus B. We can write this statement as like this also. So C of I comma j equal to, this is the logic for doing the conventional way of matrix multiplication. So k value ranges from 1 to n. So A of ik into B of kz. Now let's see how many multiplications and how many additions are required. If you see here 1, 2, 3, 4, 5, 6, 7, 8. So totally 8 multiplications are required. So number of multiplications required are 8. And now let's see how many additions are required. 1, 2, 3, 4. So 4 additions are required. Now let us see the time complexity of this one. Here we are using 1, 2, 3. So 3 for loops means the time complexity is n cube. If you have only one for loop, then n. If you have 2 for loops, n square. Whereas if you have 3 for loops, this statement will be executed thrice. So the time complexity is big O of n cube. Now let us see the second way of matrix multiplication, that is divide and conquer strategy of the matrix multiplication. If the matrix size, if the problem size is smaller, that means if the order of the matrix is 2 by 2, then we can say that the problem size is smaller. If the problem size is smaller, then there is no need of divide and conquer technique. Whereas if the problem size is larger, that means if we have more than 2 by 2 dimension, then we have to go for divide and conquer strategy. We know about what is divide and conquer strategy. We have to divide the given matrix into various submatrices and we have to conquer. Conquer means we have to solve each submatrix separately. Consider a 4 by 4 matrix. So 4 by 4 matrix means we will have order of the matrix is 4 by 4. So row size is 4, column size is 4. Here the order must be in powers of 2. That means it may be either 2 by 2, 4 by 4, 8 by 8, 16 by 16, next to 32 by 32, 64 by 64 likewise. This 4 by 4 matrix is divided into 4 2 by 2 matrices. If you see this example, so A order is 4 by 4, B order is 4 by 4. So first row 1 1, 1 2, 1 3, 1 4. Second row 2 1 1, 2 2 2, 2 3, 2 4. Next third row A31, A32, A33, A34. Fourth row A41, A42, A43, A44. Now we have to divide this matrix into, so here what is the size? 4 by 4. So 4 by 2, 4 by 2. Here we have to divide the matrix into 4 parts. We have to divide the matrix into 4 parts like this, where each matrix contains 4 by 2 by 4 by 2. 4 by 2 means 2. So 2 by 2. So this matrix size is 2 by 2, 2 by 2, 2 by 2, 2 by 2. So likewise we can divide this matrix into 4 parts, where each matrix contains 2 by 2 elements. Now let us treat this matrix as an element. So let us assume that this is A11, this element is A12, next this matrix is A21, this matrix is A22. Likewise assumes that this is B11, B12, B21, B22. Now we can multiply A11 with first row will be multiplied with first column of the first matrix. So A11 will be multiplied with B11. Likewise A12 will be multiplied with B21. So likewise we can do the process just like the 2 by 2 matrix. Suppose if we have 8 by 8 matrix, then it is divided into 4, 8 by 2, 8 by 2. Then it is divided into 4, 4 by 4 matrices. Again 4 by 4 matrix is divided into 4, 2 by 2 matrices. Suppose if you have 16 by 16 matrix, then it is divided into 4, 8 by 8 matrices. Again 8 by 8 matrix is divided into 2, 4 by 4 matrices. Again 4 by 4 matrix is divided into 2, 2 by 2 matrices. And then we will treat each 2 by 2 matrix as an element, and then accordingly we will do the multiplication. Now let us see an algorithm for this one. So it is an algorithm. So that's why we are using algorithm. MM stands for matrix multiplication. Here we have 3 parameters. The first parameter is matrix A, second parameter is matrix B, and third parameter is n, order or dimension. Here the order must be the powers of 2. It may be 2 or 4, 8, 16, 32 likewise. If n is less than or equal to 2, if n is less than or equal to 2, then we can say that the problem size is smaller. So directly we will get the solution by performing the multiplication. Already we know the formulas. C11 equal to first row of the first matrix will be multiplied with first column of the second matrix. So A11 into B11 plus A12 into B21. So likewise we will calculate C12, C21, C22. Already previously we have seen these four formulas. So if n is less than or equal to 2, then directly the solution is at our hand. So directly we can get the solution by doing the multiplications as well as additions. Else, so when this else block will be executed, if n is greater than 2, if n is greater than 2, then we can say that the problem size is larger. Then what we have to do? Simply we have to follow one step. We have to divide the given matrix into 4 n by 2 by n by 2 matrices. Suppose if the order is 4 by 4, then it is divided into 4 n by 2 by n by 2. That means 4 2 by 2 matrices. Next, here for this one, so what we are doing is we have to multiply this one. So we are calling function of for this operation. For multiplying A11 with, so this is B11. So for multiplying this one, A11 with B11, this is the recursive function call. Of, the first parameter is A11, comma B11. Now what is the size? N by 2 is the size. Plus, next we have to multiply A12 with B21. So of A12 comma B21 comma, next we have to pass n by 2. Next, what is the second one? We have to multiply first row of the first matrix with second column. So A11, next to what is this one? B12. So of A11 comma B12 comma n by 2. We have to pass n by 2. Plus of this value will be multiplied with this one. A12 and B22. A12 and B22. N by 2. So likewise totally we have to call how many function calls? So 1, 2, 3, 4, 5, 6, 7, 8. So 8 recursive function calls are needed here. So this is the algorithm for divide and conquer strategy. So when it is needed, if the problem size is larger, when we can say that problem size is larger, if the order of the matrix is greater than 2. Now let us see the recurrence relation or time complexity. First let us see the recurrence relation. So T of n equal to, so time complexity for an array of n elements equal to 1 if n is less than or equal to 2. If n is less than or equal to 2, then directly we can get the solution by doing these multiplications and additions. So we can require only 1 unit of time. So 1 unit of time is required for doing these multiplications and additions. So that's why the time complexity is 1. So 1 unit of time is enough. 1 unit means it may be 4 or 5 multiplications or 8 multiplications, any number of multiplications and any number of additions. Whereas if n is greater than 2, if n is greater than 2, then how many recursive function calls are needed? 1, 2, 3, 4, 5, 6, 7, 8. 8 recursive function calls are needed. So that's why we are writing 8 T of n by 2. Why? Because we are dividing the problem into 2 parts. So this part will be, this is one recursive function call and this is another recursive function call. So we have to sort each one separately. So that's why we are using T of n by 2 plus this n square specifies maximum we require n square additions. Maximum we require n square additions. N square 8T of n by 2 plus n square if n is greater than 2. Now let us see the time complexity here. So this is nothing but a recurrence relation form. We know the recurrence relation form, master theorem, AT of n by p, n by b plus f of n. Here a value is 8, b value is this value, n by b, b value is 2 and this function, this constant is nothing but f of n equal to n square. Then log of a base b equal to, here what is a value? 8. So log 8 base 2. So this is nothing but log 8. So we can write that as 8 can be written as log 2 power 3. Log 8 can be written as 2 power 3 base 2. So this is in the form of log a power m. What is the formula here? 3 log 2 base 2. Log a power m means m log a. So log a base a means 1. So here the value is 3. So that's why we can say that here the time complexity is big O of n cube. So in the first strategy, that is conventional strategy, as well as divide and conquer strategy also, the time complexity is big O of n cube. So we can reduce the number of comparisons to some extent with the help of the Strassen's multiplication. Strassen's multiplication is very, very faster when compared with these two multiplications. There the time complexity is big O of n power 2.81 only. So the 3 is reduced to 2.81. Now let us see the third way of matrix multiplication, that is Strassen's matrix multiplication. It is extremely faster when compared with the first two approaches. Let we have two matrices. Let A matrix contains A11, A12, A21, A22. Let B matrix contains B11, B12, B21, B22. So this is the resultant matrix. Even if the matrix size is larger, like 4 by 4, 8 by 8, then divide and conquer algorithm will be applied on them and the values will be calculated. Okay. Now these are the Strassen's rules. So P, Q, R, S, T, U, V. So these are some formulas. Next C11 for C11, for C12, for C21, for C22. These are the formulas. Now let us see how we can remember these formulas. Okay. So here the dimensions are 1, 1, 1, 2, 2, 1, 2, 2. So these are the dimensions. So first let us see how we can remember P. So P means simply we have to add the diagonal elements. So A11 plus A22 into B11 plus B22. So you add the diagonal elements and then do the multiplication on them. Next we have to remember like this. B11, A11, next A22, B22. We have to remember these four. So next four formulas are Q, R, S, T. So Q starts with B11. R starts with A11. S starts with A22. Next T starts with B22. Okay. Next, now let us see Q formula. So here left to right. So left to right means Q. Left to right means Q, whereas top to bottom means R. Top to bottom means R. Next, bottom to top means, so like this. So this is S. So left to right means, so Q is over, R is over, next S is over. So this is nothing but T. Here left to right means we have to do the addition operation. Whereas top to bottom, bottom to top means we have to do the subtraction operation. So let us see here. So first Q formula. So Q means what? Left to right. So here left means, so here we have B11. So here next the expression starts with A. If you see the next one, it starts with A. So next expression starts with B. So here we have B. So next expression starts with A. So left to right. So that means A21, which operation? Plus A22. So A21 plus A22. Next let us see R. So already we know about A11. So the next expression starts with B. B. So let us see B. So here R means top to bottom. R means top to bottom, whereas S means bottom to top. So what is R? Top to bottom. So here the expression is starting with A11. So the next expression starts with B. So B12 minus B22. So B12 minus B22. Next S. So this is S. So here we have top, here we have bottom to top. So it is starting with A. So the next expression starts with B. So B21, which operation? Minus. B21 minus B11, B21 minus B11. Next T. So it is starting with B. So the next expression starts with A. So left to right. So A11 plus A12. A11 plus A12. So next U. U is based upon S and T, whereas V is based upon Q and R. So let us see what is U here. So here we have to take the expression within the parentheses. If we have A, then write B. If we have B, then write A. So here we have B. Take the expression within the parentheses. Here we have B. So take the reverse. So A21 minus B11. A21 minus A11. Into, so take this one, reverse. In place of A, take B. So B11 plus B12. So likewise, V means based upon this one. We have to take this expression within the parenthesis. Take the reverse of A. So B21 plus B22 into, here we have B. So reverse of B means A. So A21 minus, this one. A12 minus A22. A12 minus A22. So likewise, we can write the formulas for P, Q, R, S, T, U and V. Now let us observe C11, C12, C21, C22. Here C12 means, remember, rat. Remember, a rat. So take the first one and the last one. So R plus T. So C12 means R plus T. Whereas C21 means R minus 1 and T minus 1. R minus 1 means before R we have Q. So Q plus, before T we have S. Q plus S. Next let us focus on C11 and C12. So first we have to take P. So take P here, and let us observe the first letter of C12 as well as the second letter of C21. So here the first letter of C12 is R, second letter of C21 is S. So move this S up towards up and move this R towards down. We need to perform the addition operation. So plus plus. So move this S towards the up and move this R towards the down. Next operation is subtraction operation. So for that we have to take the second letter. Here we have to take the first letter. So here what is the second letter? T. We have to perform the subtraction. So move this T towards the up and move this Q towards the down. Which operation? Subtraction operation. Next here what are the last two? U and V. So next operation is plus. So this V plus V. This V is taken in C11, whereas this U will be taken in C22. So likewise we can easily remember the formulas. Next let us see how many multiplications and how many additions are required. If you see here, so here we have 1 multiplication, 2 multiplications, 3, 4, 5, 6, 7. So totally 7 multiplications are required. Now let us see how many additions are required. Here additions and subtractions both are same only. Subtraction is nothing but addition of negative numbers. So let us see how many additions or subtractions are required. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So totally 18 additions are required. If you see the first approach, C11, C12, C21, C22, there we require 8 multiplications and 4 additions. But here we require 7 multiplications and 18 additions. Additions are very less expensive, whereas multiplication operations are very it will take more time. Multiplication operation consumes more time. It is very expensive, whereas addition operations are not expensive. They are very cheaper. So here what we are doing, we are reducing 8 multiplications to 7 multiplications. So that's why we are saying that this is very faster. We are reducing 1 multiplication operation. But we should not bother about additions. Additions are very slower. They are very cheaper. So we should not bother about that. So this is the disadvantage of status multiplications. Now let us see the time complexity. So T of n equal to 1 if n is less than or equal to 2. If n is less than or equal to means the problem size is smaller. So directly we will get the solutions. So 1 unit of time is required. Whereas if n is greater than 2, Then how many multiplications are required here? Here totally we require 7 multiplications. 7 into T of n by 2, because we are dividing that array into that matrix into 2 parts. So 7 into T of n by 2. If you have 4 by 4 matrix, then 4 by 2 by 4 by 2. If you have 8 by 8 matrix, then 8 by 2 into 8 by 2. Plus maximum we require n square additions if n is greater than 2. So for calculating this time complexity, just we have to use AT of n by p plus f of n formula. Here a value means 7, b value means this 2, whereas f of n means n square. In order to calculate the time complexity, log a base b, consider log a base b. Here what is a? 7. So 7 base 2. The value for log 7 base 2 is 2.81. So the time complexity of the Strassen multiplication is big O of n power 2.81. Whereas if you observe the previous two, there the time complexity is big O of n cube. In conventional method, in divide and conquer, the time complexity is n cube. That n cube is reduced to n power 2.81. So this is the advantage. Strassen's multiplication is very faster when compared with the first two approaches.